Over the last couple of videos, I've received multiple requests to make much simpler geometry node tutorials for absolute beginners where I speak a lot slower as well. So in today's video, I'm going to speak as slowly as possible while explaining every single detail to create this very simple abstract loop. It's going to be within geometry nodes, but I'm going to take every single step into consideration while explaining it. So with that, let's actually begin the tutorial. In our default scene, we're going to bring our cursor to the junction of these two windows right here in the bottom right and click and drag to create a new window once the mouse becomes a little plus icon. That way we get this new window and we can change this to whatever we want. So right now it is the 3D viewport and we can come to this top left button over here and switch this to the geometry node editor by pressing this button over here. Now essentially geometry nodes is a setup, it's a modifier which you can add from this panel over here as well, but essentially because it's a modifier, it takes the base geometry and makes changes or modifies it and plugs out an output. So we can create a new geometry node modifier by pressing this plus button, and now you can see we have the group input as well as the group output. So this is what object was present while we added in the modifier, and this is what is being outputted in the 3D viewport. So we want to make changes to this input before it passes out to the output. We can make multiple types of changes. For example, we can set the position of every single one of these vertices by just offsetting them on one of these axes. So maybe we can offset it on the Z, and you can see that the input geometry is being offset by 2 units, and then it's going into the output, and that's why in the output we see the initial geometry itself offset by 2 units on the Z-axis. So that is the essential base of geometry nodes, and we are going to be using that exact thing to create what we want to create. Now we don't need to add in this group input because we can create our own geometry within the node tree itself. So let's just tap the group input, and that way nothing is present because nothing is going into the group output. So let's press Shift A and then search for maybe a grid node, because this grid node is going to be a plane. If we plug this into the group output, we can see that we get a grid that just looks like a plane. To see whether it's a grid or not, we can actually switch on wireframe view by pressing this button over here, and that way we can clearly see that there are 3 vertices, one here, and one here for each of the axes. So that way, for the X and the Y, we get this sort of a setup. Now we need to actually increase the size of this, so we can change the X and Y size to make it much larger. So let's change the X size to something like 10 and the Y size to 10 as well. But right now you see that there's still only 3 points present on each of these axes. On the X there's one here, and one here, and on the Y as well, one here, and one here. So that way we have to increase this by increasing this X and Y vertices over here. So let's go ahead and make this something like 20 and this something like 20 as well, and now you can see how many more points were created on each of these axes. So remember that when we say that there are 20 vertices on the X, there's going to be 1, 2, 3, 4, 5, 6 all the way to 20, and when we say 20 on the Y, there's going to be 20 like this, but it's not just the ones on the outer edges. All of these inner points are also considered as vertices, and we can use them as points in the later parts of this tutorial. So let's just shift this back and then press Shift A and search for an instance on points node. So what this instance on points node does is it takes in a number of points and then plugs out instances by placing some object as an instance onto every single one of the points that we choose. So right now this mesh, we just saw that there are multiple points present in this mesh. Essentially a point is equivalent to vertices if we don't mention it separately. So every vertex of this mesh is a point for this node. So we can plug this in, and now for the instance we have to plug in something that will be put onto every single one of these points. Let's put in a cube. So let's press Shift A over here and press cube in our search bar, and then we can directly plug this in for the instance. So that way on every single one of the points we will be placing this cube. Now obviously I don't want the cube to be this large because it's going to be 1 meter by 1 meter and there's going to be a lot of overlap. Right now we can't see the cube because this output is not going into the group output. This mesh is directly going into the output, and that is what's seen. So we can remove this connection and plug in this into the group output, and that way you see there are cubes on every single one of these points. We can switch off wireframe view, and now you can see that there's a lot of overlapping as well. So let's reduce the size of this cube by changing the size on the X, Y, and Z to something much smaller. Let's go with 0.2, and now you see we have these small little cubes. Maybe we can increase these even more. So just keep playing around with this value until you get something that perfectly snugly fits just like this. So now we have this cube present on every single one of these points from the grid. The next thing that we want to do is actually move these up and down based on some texture. So we can actually move all of these by pressing Shift A and searching for a set position, as we've already seen. However, now is a good time to understand the different types of inputs to geometry nodes. So if you actually take a look at one of these options like this, you see there are some round sockets like this, and there are some diamond shaped sockets like this. So the round sockets are things that work for the entire geometry as a whole. You don't have access to the individual points or the individual vertices for every single one of these objects, and everything that has these circular nodes are going to happen for the entire object. On the other hand, these diamond sockets happen for every individual vertex or individual face or individual edge. So that way, when we take this offset, if we were to just use a single value over here, let's say 1, the entire thing is going to move by 1 unit on all of the axes. But you don't have to do it for every single one of the vertices. You can control each vertex separately. So each vertex has an index, and that's what's going to be used while creating the offset. Let's press Shift A and search for a noise texture. If we look at the output from the noise texture, we see that this is also a yellow colored dot, but it's not a dot, it's a diamond. So this diamond implies that every single vertex will get a different value from this noise texture, and it's not the entire object that's going to get that value. So we can take this and we can plug this into the offset, and that way you can see every single one of these points are moved by a random value, but each point is moved differently. Because these are instances, every instance acts as a whole, and you can't actually move the individual points within an instance. Every instance will act as a single object. That's why each cube still remains as a cube itself, and each cube is what moves up and down based on this noise texture, and not the individual vertices. On the other hand, if you press Shift A and search for a Realize Instances node, that way all the instances become real geometry, and then when you use this noise texture, it'll move every vertex separately. So let's plug this Realize Instances node right here, and now you see the noise texture is moving each vertex independent of the other vertices, and that's why you get this jumbled mess just like this. So hopefully now you understand the difference between instances and actual geometry, which you can create by realizing the instances. Now let's plug this directly in and remove this Realize Instances node, because we want these cubes to actually remain as cubes. Now for this noise texture, we can change the scale and all of that to make it much smoother. Maybe we can reduce the scale to 0.1, and that way you see we get this nice wave-like pattern. And the best part about this is that you can always change this and animate this over time, and you can see how we get slight motions present. There's a lot more that can be done. Let's say you want to actually move this even more. You can search for a vector math node, and you can use this after the noise texture by plugging it in here and changing this from add to maybe multiply, and just multiplying it by large numbers on different axes. Let's say I wanted to move only up and down. I can multiply it by 0 on the X and the Y, and multiply it by a very large number on the Z, and now you see you get this really exaggerated up and down motion, and when we change the W, even that motion is amplified just like that, which looks pretty cool. Now you could keep this itself as an animation. However, I don't want to show you how to loop noise textures in this video itself, and instead we're going to use a wave texture. So let's remove the noise texture and press Shift A and search for a wave texture. Now this wave texture is essentially going to create multiple waves, and we can see that by just plugging this into the multiply socket and changing all of these to 1, so that we essentially get the wave without any distortion or any multiplication, because multiplying it by 1 is essentially the same thing. So now if we were to just reduce the scale down to something really small, you can clearly see how the wave is formed, and you can use this phase offset to create this sort of a motion. Now you see it's actually moving towards the top right, and that's because this is a yellow dot, which means it's giving out color outputs, which means it has all X, Y, and Z values present with it. It has 3 values, which is actually the RGB, but while we're using a vector math node, the RGB is equivalent to the X, Y, and Z. If we were to multiply it by 0 on the X and the Y, it'll move only up and down, and now when you use the phase offset, you can see the exact wave that you want. However, I don't actually want it to be on this X-axis as is, so I'm going to change this from X to Z, and instead of having bands, I'm going to create rings. And that way, we should get rings of these waves as we change the phase offset. But this still isn't exactly what I want, and that's because we switched back to X. We'll change that back to Z, and now you can see how we get this wave, but it's still a bit too small, so let's reduce the scale even further until we get it to be nice and smooth. So now reducing it, you can see that by about a value of something like 0.1, we get this really nice smooth wave motion as we change the phase offset. And that is essentially the animation that we want. Now this phase offset is actually taking in radians as the input, and radians is a type of measurement of angles just like degrees, except one full rotation is 360 degrees, but in radians it's equivalent to 2 pi. So now we have to write 2 pi over here to get one full rotation. So we'll do that in the animation section. For now, we know that if we change this phase offset, we're getting the exact animation that we want, and that's actually all there is to creating the geometry node tree. This is the basis for geometry nodes. However, because geometry nodes can have multiple branches and you can add in even more geometry within this node tree, what we do is we have to use a set material node so that we can actually give materials to different objects. So let's take the set material node and plug that in right here. And along with that, if we don't want hard normals to be present, or you see these edges are present, we don't want it to be too sharp, we can actually press Shift A and search for a set shade smooth node. So that way you can see how these edges are no longer sharp and they become smooth. Now, of course, this doesn't look like the smooth shading that we want. However, we'll fix this in a second. For now, we can set the material by selecting any one of the materials from this drop-down list. You can create your own materials by going to this material property and either pressing the new button if a material is not already present, or else pressing this button to add in a new material slot with a new material by pressing that new button. However, we don't want these new materials. We'll use this default material. We'll just change it to tiles. Now, in the set material node, we'll go ahead and select that tiles material that we just created. And now we can actually make changes to that material. Before we make changes to that material, we have to start fixing off this edge shading that we had. The way I want to fix that is by adding in a bevel modifier. The problem with just adding in a bevel modifier from the modifier panel over here is that when we add it in, you can see that there's absolutely no beveling actually occurring. Now that's happening because this right now are all instances. And remember, we don't have access over individual instances and we can't make changes to that particular geometry. So we need to convert it from instances to real geometry. And right now you see that the geometry node tree also disappeared. And that's because when you have the geometry node tree, you need to have the same geometry node modifier also selected. So when you select the same geometry node modifier, the geometry node tree will appear. Now, within this tree, let's press Shift A and search for a realize instances node to convert it from instances to actual geometry so that we can bevel each of the edges. So as soon as we realize it, you can see how the bevel started working. Let's just decrease the amount from 0.1 to 0.02 and then just increase the segments from 1 to 2, and that will create this nice soft edge instead of that hard edge that we had before. If we just hide this bevel modifier by pressing this button, you can see that we have these sharp edges, but once we bring that back in, you can see that we have these nice round edges over here. Now that's all for actually modeling this thing. Let's start the animation. Before we animate, remember, an animation is a bunch of frames or a bunch of pictures that are played per second. So you can decide how many of these pictures you want per second in this frame rate that's present in the output properties. So I'm going to change the frame rate to 30 frames per second, which means there will be 30 images rendered for each second of the video. Along with that, my output frame I'm going to keep at 150 so that it's just a 5-second long animation. The output folder, you can choose the folder that you want. If you put // it will be saved in the same folder that you save your Blender file in. So remember to save your Blender file, because if you don't save it, your output will not render. Then you can switch off file extensions if you are giving in the name of the animation. So maybe I'll call this abstract wave.mp4. So when I say abstract wave.mp4, this will be saved as abstract wave.mp4. And because I'm saying .mp4, I don't want it to add in another .mp4 using this file extensions. Now, since I want to render out an animation, I'm going to change the file format from PNG to FFmpeg video, and the encoding, I'm going to change the container from Matroska to MPEG-4 with an output quality of perceptually lossless. So that way, it's going to definitely render out really fast and become a single video at the end. Now that we have that done, let's start the actual animation. Remember, the animation is done using keyframes, and that's present in this timeline over here. So we can just drag it out so that we can see it a bit better, and we can add in keyframes wherever this blue head is, and that is where your actual area of the animation is. So let's go to frame 0, and there we'll just hover over the phase offset and tap I. But before we do that, we'll change the phase offset to 0, and then we'll tap I to add in a keyframe. To see the keyframe down here, you have to make sure that you have that node selected, and if the node is selected, the keyframe should appear down here. Now we can go to the last frame, which is frame 150, and offset it by 1 full rotation. Remember, I said 1 full rotation is 2 times pi, so you have to say 2 asterisk pi. Now, if you don't want to type this in, you could actually type in TAU, which is also equal to 2 times pi. So now, once you have that value set in here, you can just press I to add in another keyframe that'll appear over here. Now, if you were to just play the animation by either pressing this button or the space bar, you'll see that this actually starts off pretty slow and then slowly speeds up in the middle. Along with that, it's going very slow because the frame rate is actually dropped down to 8 because we added in this bevel modifier and things like that. To get a realistic idea of how fast it's playing, you can switch the playback from play every frame to frame dropping, and that way you'll see how fast the wave is actually moving. But in the process, you'll have a lot of frames dropped and not rendered. So now when you see it, it actually slows down and stops at the end. And that's because the interpolation between these two curves is set to Bezier, which means it tries to smooth it out and cause a nice smooth start and a smooth end. Now, because it's smoothing out that start and end, it actually seems like it's slowing down and stopping at the end, and it's slowing down before it starts as well. So we don't want that. We want it to act like one single loop. So we're going to come down here and press the letter T to make this pop-up window come up, and we're going to choose the interpolation type as linear. So when we choose this and we actually play the animation, you'll be able to see that it's going as a single loop and there's no seam or anything, and it looks like it's just playing forever, although it's only 150 frames that's just repeating again and again. So that looks perfectly alright, which is exactly the way we wanted it. However, we now have to start texturing and creating the rest of the scene. So let's switch this over to the shader editor, and let's switch our viewport shading to rendered so that we can actually see what we're rendering. Along with that, we don't want this default light, although you could keep it if you want to have some nice shadows. But since I don't want any shadows, I'm going to remove the default light. Then I'm going to go to my world properties and change this background color all the way to white so that it becomes very bright. Now, the issue with doing this is that everything else also becomes very bright, and it's really hard to tell what anything is. So what we do is we actually go to the output properties over here, or the render properties, and we switch on ambient occlusion, which enhances the shadows whenever things are close to each other. Now we can actually decide how close they have to be to create the shadow by expanding the ambient occlusion tab and increasing the distance. So that way you can see how we're able to increase the amount of shadow present. So maybe I'll increase the distance to something like 5 meters, and that way we just get some nice shadows. Along with that, I'm going to switch on screen space reflections as well so that these objects can cast their own reflections on each other. Next, with this object selected, in the shader editor, I'm going to choose the tiles material, and if I can't see any of the nodes, I'll just press period on my numpad to centralize the nodes. If that doesn't work, press A to select all the nodes and then press numpad period, and then everything will get centralized. Now for this material, I'm going to change the metallic all the way to 1 so that there are nice reflections, as you can see. And to enhance those reflections even more, I'm going to change the roughness down to 0.4. Apart from that, I'm going to change this base color from this white to an even brighter white, and I'll give it a slight bluish tint just like that. Once I'm done with that, I want there to be some dots on the surface of these objects. For that, I'll press Shift A and search for a Voronoi texture. And if we actually Control-Shift-click it with the Node Wrangler enabled, you'll be able to preview what this actual shader looks like. Remember, you can either go to your Edit Preferences, Add-ons and enable Node Wrangler, or you can just connect this up to the surface directly to preview the node. Now, this is obviously not what we want. So for better control, I'll press Shift A and search for a color ramp node so that we have control over the output of this Voronoi texture. Now I can take this black slider and just drag it in, and take this white slider and drag it in, and now you can start seeing that we're seeing some sort of circles being formed. Let's get more of these circles by increasing the scale of the Voronoi texture. Now let's just change the color of these circles by flipping this white over to the other side so that we have black everywhere and white color circles. Now we can make these circles even smaller by bringing this black in, and that looks pretty good. If you do want white color surface and black color spots, you can always flip the color ramp once again. Now, the closer you bring this, the sharper the dots are going to be, and I think this is good enough for the distribution. Next, I don't want this white area to remain white, so I'm going to change this from white to that same pale bluish color that I had. And now I'm going to plug this into the base color of the principled BSDF, and I'll plug this into the surface output of the material output. Now when we actually look at it, this is what we have, and that looks pretty good. But there's one issue. The first issue is that it's scaled incorrectly on this horizontal axis, and along with that, when we actually play the animation, you can see that these Voronoi textures are actually changing. There's a sudden dot that appeared over here, and now it's gone again. Now another one appeared over here. So it's really hard for us to use that. So the way we fix that is by actually changing this from 3D to 2D, and that way there's no longer depth information in the Voronoi texture, and they're just going to stick to that particular surface. If you were to start playing the animation, you can see that they're actually staying in the exact same place and they're not moving around at all. However, the issue with this is that whenever these dots are intersecting with the edges, the line is completely shown through the edge as well, because it's a 2D texture being stretched in 3 dimensions. Obviously, that's not something that we want, and we want these edges or these sides to be completely white. For that, you're going to have to change the material either over here or in the geometry node section. Since the focus of this tutorial is making changes in the geometry node editor, we're going to show you how to make changes to this in the geometry node editor. The first thing that we'll do is switch back to the geometry node editor, and there, before this set material node, we're going to use another set material to set everything as a different material. So let's take this set material and press Shift D and plug it in right there. And now we're going to choose another material. Let's go to the material properties over here and then press this plus button to add in a new material slot and then choose another material. Once you create this new material, we'll call this sides, and now we're going to choose sides over here. Now this sides is going to be whatever material it wants, but the problem is that it is being completely overwritten by this next set material. So everything gets this sides material initially, but then everything is also getting this tiles material, and that is what's going to the output. So to prevent this, we need to select only the faces that are facing upwards. So to get the direction in which every face is pointing, you can search for something called the normal node. So we can actually figure that out using something called the dot product. So this normal node has values equivalent to the x direction, y direction, and the z direction, and it tells us how much or in what direction the surface is pointing towards. if we were to draw an arrow perpendicular to the surface, which direction would this arrow point in? That is what the normal node tells us. So we can press Shift A and search for something called a vector math node, which is actually a bit more advanced than most geometry node tutorials would require you to know. However, if you want to know more about different vector math operations, you can check out this video over here where I've gone into detail and visually explained the different operations that are possible using a vector math node. Now, in our case, we're going to be using something called the dot product, which will tell us how closely a given vector aligns with some other vector that we want to check it with. Since we want to see if the normal is pointed perfectly in the z direction, we can plug the normal into the first socket and have the test vector as something in the z direction. Once we do this, we need to compare if this output is greater than 0, that means it is pointed in the upward direction. So let's press Shift A and search for a compare node, and then simply plug this value into the first socket and check if it's greater than maybe some small value we'll give so that we don't get the small bevel edges. So let's say 0.1. And now we can take this result and plug it into the selection so that only the surfaces or the faces that meet this criteria where the normal is pointed in the z direction, only those will get this tiles material and the rest will remain with this sides material. So let's plug this into the selection, and now you can see all of these sides get the sides material and only this top face gets this tiles material that we created. So now we can play around with the sides material by going back to the shader editor and this time selecting sides from here. And again, if you don't see the nodes, tap A to select everything and period on your numpad to centralize the nodes, and we'll give it the same value as we did for tiles, except we'll not add in that Voronoi texture for the actual base color. For the base color, we'll simply make it just as bright and we'll just make it that same blue. If you have trouble matching the blue shades that you've used, you can actually select the tiles material, hover over this color that you had and just press Ctrl C while hovering over it. Then you can choose the sides material, hover over the base color value over here and just press Ctrl V. That way the colors will perfectly match up and you will have the perfect setup for this. Now, if you don't want to see these orange outlines or maybe this floor and all that, you can just switch off overlays by pressing that button up here. And now you can see what the animation looks like. But obviously when we render this out, we need to render it from the perspective of a camera. So let's select this camera and press Alt G to clear location and Alt R to clear rotation. Now let's switch on overlays just so that we can see the camera, and we'll press GZ to move the camera up on the Z axis by quite a bit. Then we'll press RX and we'll just rotate it by some amount, and to actually see how much it's rotating by, we can press 0 on our numpad to go into our camera's view. Now you can see that we've rotated and we're completely outside the actual cube. So let's press GY and move it back till we bring everything back into frame. But right now a lot of it is outside the frame as well. Only the things that are inside this region will get rendered. So to make those changes, let's go to our camera properties by pressing this button over here, and we'll just expand viewport display and we'll change this passport out all the way to 1 so that we can see exactly what's going to be rendered. Now we'll also change this focal length to give it a more wide angle field of view so that we can see more of the surroundings, and then we'll just press GZ to bring it down, and I think some sort of a look like this is actually good enough for the animation that I wanted. So now we can just switch off overlays and this looks pretty good. Remember, you don't have to keep it like this. You could always rotate it about the Z axis as well by maybe 45 degrees. And we can then move it on maybe the local X axis to just bring it to the center again. And now we have some sort of an angled look for this particular animation. Now, the best part about geometry nodes is that everything remains modular. At any point of time, we can go back to the node tree and we can change different aspects or different things that we had. So for example, let's say there's white areas here, so I'd want to expand the region that's being rendered. So what I can do is increase the size on the X and the Y from 10 meters to maybe 20 meters. And similarly, because now the vertices are much wider apart, we can increase this as well by 2 by changing them to 40. And that way you can see that now there's no white spaces over there because the entire plane has been added or expanded to meet those regions as well. So that's the power of geometry nodes, and it makes everything a lot more modular. So you can go ahead and change whatever you want and plug that into the output and have various animations as well. It's very useful, and I hope you learned something useful from this particular tutorial. Once you're happy with the way everything looks, you can always go to render and choose render animation. Thank you so much for watching till the end of this video. I know it was much slower for many of you that follow my regular tutorials. However, I decided to make 1 or 2 very simple, basic tutorials for absolute beginners as well. I post videos every single day, so there are a lot more fast-paced tutorials that are present on my channel, and I'm sure you'll make the most out of all of them. I go step by step, so even if you don't understand everything too well, trying it out and practicing and making multiple variations will allow you to get a feel of geometry nodes, and you'll be able to make these by yourself, and you'll be able to follow along much more advanced tutorials before you know it. So hopefully this was really helpful, and until the next video comes out tomorrow, thank you so much for watching once again. Don't forget to keep creating and always stay creative.